Hi there. Thank you so much for joining me in this instructional demo at AU 2020. I am Krishnan Ramachandran. I'm a senior software engineer at Autodesk. I work on the Arnold rendering team out of the London office. Prior to joining Autodesk, I was working as an R&D engineer on hair and grooming tools at D&G in London. I've also held the role of a pipeline and tools developer at Blue Sky Studios in Greenwich, Connecticut in the US. Our main objective for today is to render a production level scene like this with Arnold while using different software applications in your pipeline. Before we begin, if you're not familiar with Arnold, here are a few key points. Arnold was one of the first production path tracers, something that was recognized by an Academy SciTech Award. Arnold scales well for production scenes and tackles complex rendering challenges such as skin, hair, volume that are needed in feature films. Arnold is customizable through a powerful API that's available in both C++ and Python. As you may know, we now have a CPU and a GPU render, and you can switch live from one device to another. Arnold now ships with Max and Maya and is the default renderer. Arnold is also integrated in Houdini, Cinema 4D, Katana, and is also available in some unsupported applications like Gaffer. Another aspect to note is that we try and release as often as possible, once a month more or less in general, but Cinema 4D did about 19 releases last year, so it can be a bit more. In the past few releases, we've fixed many bugs which came from user feedback. A huge thanks to our testers, beta testers, and all studios who've reported back issues. We are continuing to improve the CPU compatibility by adding new features, new shaders, such as the UV camera for baking or the shadow matte shader. Recently, we've also added OSL texture and trace support on the GPU. In terms of node support, we're getting really close. We're just missing a few shaders. We've also been collaborating with NVIDIA to load textures on demand on the GPU instead of loading the entire textures up front. As you can see, this helps in reducing the time to first pixel. And it also reduces memory consumption. Note that this is a work in progress and we expect bigger savings as we go on. Let's get back to our main topic. This demo is titled Material Transfer in Production using Arnold and MaterialX. To that end, we're going to be taking some production assets across different software applications using Arnold. We'll also talk about how we can use some strategies to make your pipeline highly flexible and build components that can be reusable. But first, we'll need to answer the question, why is material transfer important? A modern production pipeline uses many different applications. Each of those applications support a variety of file formats. From a rendering perspective, the most important component is your material description, also known as looks. Let's say, for example, we've built a nice material for a cloth in Maya, and we're going to simulate this cloth in Houdini. Having the look of the cloth available to the simulation artist in Houdini would help the artist understand the nature of the garment he needs to simulate, and thereby give him all the information he needs to get the best results out of the simulation. Current workflows involve duplication of these looks to suit each software's requirements, and they also come with complex pipeline tasks that are hard and laborious to maintain. Arnold can help you solve the problem of being able to transfer asset materials across various stages of a pipeline without any loss of fidelity. Arnold users are free to use a software tool of their choice without worrying about their asset looks. So what we are going to do today is take a fully finished environment from 3ds Max, a character from Maya, and import them all into Houdini while retaining the ability to make changes to your asset. Specifically, we're going to take the environment from Max and export it into MaterialX and Arnold's own format. We're going to take a character from Maya and export it into Alembic and Arnold's own format and bring everything into Houdini and make changes along the way. Let's take a quick minute to talk about all of these different file formats. MaterialX is an open standard for transfer of rich materials and look development content between application and renderers. This originated in Lucasfilm in 2012. This is currently an open source project, and Autodesk is an active contributor to this project. Alembic is fairly popular. It's a format that most people use for transfer of geometry data across applications. Arnold ships with its own file format, the Arnold scene source. It's pretty extensible with the C++ and Python API. We're going to be using MaterialX, Alembic, and Arnold through the course of this demo. What we will not be talking about is USD, as there's another talk at USD that focuses exclusively on USD. This is the talk that's presented by one of my colleagues, and I would highly encourage you to take a look at this talk as well. So let's jump over to Max. All right, I'm going to open up a scene in Max, which is a kitchen. As you can see, this is a beautifully modeled kitchen with a lot of geometry, different kind of materials, everything you would expect to see in a kitchen. Let me quickly switch to the perspective view so we can look at how this looks at from the outside as well. So yeah, nothing too fancy, just a simple environment, a bunch of lights, a transparent window, so many different types of materials in the scene with chrome and transparent and diffuse. Geometry wise, this is pretty densely packed with a lot of different items. Okay, now let's quickly open up the material editor, and yeah, we can see there's each of these different geometry bits have different materials that are driving them. Some of them have a good size shading graph. For example, let's pick yeah, so this is the brick wall that's behind this environment, and you can see it's a standard surface that's driven by a bunch of shaders and other texture nodes. And there are also quite a few materials that are just a shader, not being driven by too many, like that door right here or that window. So these are, you can say, fairly simple shader nodes. So this is a good mix of all kinds of shading nodes. Let's quickly open up the Arnold render view, set the right camera, hit render, and see how this looks. So what's happening right now is the whole scene's being converted to Arnold, and we're going to start seeing the render appear fairly quickly. And once the conversion is done, you can see the scene is fairly interactive. We are able to move around the scene. Let me set the right camera here. Yeah, so once I set the perspective camera, you're able to see that we're able to move around the scene, and IPR follows along smoothly. This is what you would expect. Move around the scene, IPR refreshes, and it is pretty snappy. So I'm going to quickly stop this now. So this is what it's supposed to look like when it's completely done. Some really nice beautiful lights that's coming through the window. Right, I'm going to close this now, and let's go take a look at the render setup. So what we're going to do now for an example is get the entire scene exported as an AS file. Remember, I'm going to be exporting everything that includes the geometries, the camera, everything. Once we export that, okay, here we go. It's been exported. So I'm going to open up a new scene and just bring in the as procedural that we just exported. Let me go here to the Arnold menu. Oh, it's right there. Yeah. So let me go to the Arnold menu, create a procedural, set it to the kitchen file that we just set, and here you go. So the entire kitchen scene that we had previously exported into a single Arnold procedural has been brought back into Max. It still retains all of its geometric information, so we can hit render and expect to see the exact same results, because all of its look and the geo is just in that single procedural file. So this is already something that you can take into Maya, and you can take into Houdini, you can take into any other Arnold supported product, because this is in Arnold's native format. You can see it's really snappy, because there is no time that's going to be spent doing any type of translation here. Let us now switch back to our original scene. Here we go. So what we are going to do this time instead is we're going to separate the geometry from the materials. So I am going to just select geometry, unselect everything else, and export this file as kitchen-go.as file. Here we go. The export's done. As the next step, what I'm now going to do is I'm going to take all the materials and export it into a MaterialX file. So I'm going to call that kitchen-looks.materialx. So what this is going to do is all the geometry is now gone into an as file. All of the look is going to go into, all of the materials is going to go into a look file, and you can customize the look name, and I'm just going to call this default for now, and let me hit export. Great, wonderful. So let me just open up our Explorer and see if all the files are there. That's the first one that we exported. What we're going to be working with right now is Kitchen Geo and Kitchen Looks. Okay, back to a new scene, create a procedural again, set the file. So now all this has is just the geometry, right? It has absolutely no looks to it. It does not even have a default look. So if I were to render it right now, I'll be getting a whole lot of errors. And I'm just going to set this to, bounding box, so it's fairly fast for me to draw, but I can still see where spatially I am and set my viewport camera. These are just these convenience things that you have that you can use. Okay, so I need to open up the operator graph and create a procedural node in here. I'm going to call this procedural node kitchen_look assign and create a MaterialX node. Connect the MaterialX. So this is an operator that we are creating, and I'm going to set the MaterialX file that we have created. I'm going to set the selection to star, which means apply everything that you find on anything that you can apply it to, and select the look, which is going to be default. And in the procedural, I'm going to select the operator, which is what we just created, which is the look assign operator. There we go. And let's render again. Things. There you go. So we've separated our geometry from our looks, but you can still see the exact same looks are applied to every single object. So if you get in close to all these picture frames, you can see all the textures that the picture frame had. You can see the bricks, you can see the definition on the bricks. You can see that the whole scene has got the exact same shading applied to it. So what we've done so far is export a kitchen environment from 3ds Max. Specifically, we've exported the geometry as an Arnold procedural, and we've exported all of its looks into a MaterialX file. Next, let's head over to Maya. Right, so I have a simple scene with a sky dome light and a plane. And the sky dome light is actually turned by an HDR texture, and I have a bunch of materials in the scene. So what we're going to do is we're going to do look dev on a character, but we're going to look dev on a character that is an Alembic file. So one way to bring an Alembic file for look deving in Arnold is using the stand-in. The stand-in is a proxy representation shape of the Alembic file itself, but it gives you a few more options on top of it. So let me import the geo. You can see when you import the file, you actually have in the stand-in node a bunch of options, one of them being how you want to draw it in the viewport. And another thing that this UI gives you is the complete hierarchy of the Alembic file that you loaded in. To know that you just does not have to be Alembic only. You can also have USD files. You can have Arnold procedurals as files in here. So all of those are supported. Now let's see how we're actually going to be doing look dev on a scene like this. Let me just turn 3D manipulation on, so it's easier for us to drive this. Okay, so one way what you can do here is you can actually select something in your viewport, and you can have that be selected in here. So you can see that I had selected the suit shape, and the geosuit shape is actually selected, and here you assign a shader to it. And what I'm going to do here is I have the suit material, so I'm just going to assign the suit material to it, and boom, you start seeing the suit material appear. That's what you can also do alternatively is you have a filter. So I can search for hair, and I can actually see the hair shape, and I'm going to add another shader to it, and I'm going to set that to hair material. And there you see the material being applied. So you can actually start applying your materials through this. What this does is, instead of making a direct assignment on the shape, this actually does a rule-based assignment in Arnold. So what it does under the hood is create a set parameter operator, and the set parameter operator says find the geo that has this selection string, and if it has this selection string, apply the shader add material to it. So you will find where this is actually going to be really helpful when we go to animation and places like that. So hang on to that. I'm just going to go ahead and get the entire item done now. So this is how the character is expected to look when the look is complete. He has a bunch of materials that's riding his jetpack, his suit, and his armor, hair. Now that this assignment is done, you can actually take a look at the stand-in view to see what's going on. So what we have done, let me remove this filter. What we have done here is we've set a material, which is a suit material, on all of it, and then we have some local overrides on it. For example, the knee pads. The knee pads have a metal material applied to it, and the jetpacks have the jetpack material applied to it. So on top of that, we also have a few other overrides that we've applied to it, like the subdivision type and the displacement value and things like that. So this, basically what it does is it lets you set an assignment which does not closely coupled with the geo and the geo name itself, and it just sets it by a name based string. What this has done is it's grouped all of the changes that we have made. So all our shader assignments, all our geometry overrides, all of them have been grouped under this default look. Anytime you create a stand-in, it comes with a default look. And what we're going to do now is create a look that's based off of the default look, but significantly different. So let's create a new look, and let me call that Sven underscore red. I want it to be a duplicate of the current look, so I wanted to mostly keep all of the assignments along with the geometry overrides that we have done, but we're going to make a few tweaks to it. So what I have in my scene is I also have a different material for Sven's suit, which is red. So let me select Sven's suit. There, Sven's suit selected, and I'm going to replace suit underscore material with suit underscore red material. So you can see there's a red looking material that we have. This is done in a non-destructive way. So you still have your default look, which is your blue look, and you also have Sven's red look that we have just created. So what I want to do now is I want to change the shade. I want to change the materials that are applied on the shields that he has on his forearm. So let's go ahead and create a completely new material. So let me create a standard surface, and I'm going to call this copper underscore material, and I'm just going to use a preset copper on it. So let me select his forearm, and there's his forearm. Let me assign a new shader, and let me assign copper material to it. There you go. You have a copper looking forearm that Sven's red variant has. Let's do the exact same thing on the other forearm as well. Get the forearm selected, create a new shader, and let's apply copper on him. So here we go. We have two fairly different looks. One is Sven's default look, and we have a variant red. So what I also want to do now is create a debug look that might come in handy for us to inspect and debug Sven whenever we want. So I'm going to create a third look. This time I don't want it to be duplicated by the original look. I want it to be completely different. So I'm going to create a debug look. So with this debug look, I want to assign a new shader to it, and what I want to assign is a utility shader for debugging. So let me set AI utility. I want it to have primitive IDs, and I want it also to have an overlay of uh, polywire. So what we have right now in a nice non-destructive way is three very different looks. So we have Sven's default look. We also have Sven's red look with his copper forearm, and we also have a debug look. So let us go ahead now and export all of these and write them to disk. Let's take all of the looks along with all of its variants and export it to disk. Let me hit that button, and I am going to call this Sven underscore looks. So there's two ways in which we can export. We can export this as an Arnold operator graph, which will write it out to a .ass file, or we can also write it to a MaterialX look file. Both of them will work fairly similarly. Let's go ahead and export that look, and it's done. Back to our basic lighting scene again. Let me create another stand-in and bring back Sven's T-pose. There we go. So this time what I want to do is bring in all of the looks that we just exported, but as an include graph operator. So let me create an include graph operator, and in the include graph operator I want to go ahead and bring in the Sven's look file that we just exported. By default the first look is already applied to it, but we still have Sven's red look that we created, or the debug look that we created. So all of these are still available to us. What's more is if you want to go ahead and ignore all of it and create a completely new shader, we can still do that. You still have complete control over this. So let's create a new shader, and let's assign the metal material to all of it. You can see you have a steely looking Sven. If you want to do that, this is still possible because you have complete control and all of this is still live. If you don't want that, just disable it and you go back to your include graph and you have Sven's red and Sven's debug. And in our lighting scene, this time, let's go ahead and bring back the stand-in again. So instead of using the T pose right now, what I'm thinking of doing is actually bringing in animation. So let's bring in Sven's animation, and let us also import the camera. So here, if we render, yeah, we see Sven in an animated pose, and we can see that he has some animation on it. So none of the materials have been applied to it as expected. You know, this is just the alembic that we've imported. But what we can do now is we can go ahead and create an include graph operator and bring in the file that we just made. So there is the include graph operator. Let's bring in Sven's look and set default on him. And you can see Sven's default look starting to render. What we can also do is switch to Sven's red look with his copper forearms or debug. So all these three are still available for us to just attach onto the scene. Just to make things more interesting, I'm going to be bringing in the kitchen scene that we exported from Max into Maya along with Sven's animation and look at them together. So let me create a stand-in, and in this stand-in let's bring in the kitchen, and let me create another stand-in, and in this other stand-in let's bring in Sven's animation. Let me set the kitchen to be per object bounding box because there's going to be way too much information for us to draw, and let's set Sven's animation to be shaded. So what we're going to be doing now is bringing their looks and their material information for both the kitchen and Sven and apply it. So for Sven, let's create an include graph operator, and let's bring in Sven's look from last time and set it to be default. And for the kitchen, if you remember, the kitchen was exported as a MaterialX file. So this time we're going to be bringing in an AI MaterialX operator. And let's go to the operator and let's find the MaterialX file, which is called kitchen-look.materialx, and we just had exported a single look. So we have Sven's look, and we have the kitchen's MaterialX file that's been enabled as well. Let's hit render, or before that, let's actually set it to the right camera, and we have the right camera. Let's hit render and see what we get. There we go. We're starting to see Sven in the kitchen environment. So the entire scene is being represented by the two stand-ins, and we still have all of Sven, and we still have access to his looks. So if we want to change it to a red look with his copper, we can. If we want to set it to a debug, we still have all of those functionality. What we have done with Maya now is export a character into an Alembic file. We've taken all of the looks and the variants that we made for those looks and exported that to an arnold.as file. Next, let's head over to Houdini. We're going to be importing both the kitchen scene and the character into Houdini and start putting them together. Here we are in Houdini. Let me start by creating an Arnold procedural node. I'm going to call this Sven, and let me bring in Sven's animation that we just imported in Maya. There's Sven's animation, and let me create another procedural node, and this I'm going to use to bring in the kitchen geo. There's my kitchen geo. Let me rename this to be the kitchen. So let me set the kitchen to be bounding box per node, and let me set Sven to be polygon, so we can actually see what's going on. Right, so there's Sven's animation. So right now, all we have done is just import the two procedurals. We have none of the materials imported, and yeah, nothing else that's been brought in. So let's go ahead and do that. For that, I'm going to create a ROP network. And in the ROP network, let me create the Arnold node, and I'm going to create an include graph operator. And in the include graph operator, I am going to be bringing in Sven's look and set it to be the default. What I'm also going to be doing is bring in a MaterialX node and set the kitchen's look as the MaterialX file here, and the look to be default. Next step I want to do is bind these looks to the geo. So let's go ahead and do that. So here's when we switch over to the Arnold tab, activate the operator graph, and select the include graph node that we just created inside the ROP network. I'm going to do something very similar for the kitchen. Select the kitchen node, go to the Arnold tab, turn on the operator graph, and set the MaterialX. So if you remember, the looks of the kitchen is a MaterialX file. The looks of Sven, our asset, is an Arnold procedural. So we've brought them all into the scene, and we've bound them together. So what we are also going to be doing is bring a lighting rig for this whole scene as another procedural. So let me call this lights, and I've pre-exported all of this as the lights file. So yeah, now we have Sven and the kitchen and our lights, and we have all of the looks bound to it. Let's hit render and see what we get. Looks like we have Sven in the kitchen with the lighting the way we set up in his blue costume. So let me, yeah, that's exactly what he's doing. Okay, so let me quickly go change that to Sven's red costume, and there we start seeing the scene re-render with Sven's red costume. Debug would also work exactly as we expect it to. So the debug shader is applied to it as well. So we have the entire functionality, all the looks that we exported with Sven available for us to use in here. So let's take a scenario. So for whatever reason, we get a note back saying we have to bring in another copy of Sven and apply a different look to it. Let's go ahead and do that. So let me bring in the Arnold procedural in again, and I'm going to be bringing in the same animation of Sven. Yeah, let me just move him a little to a different direction. There we are. I'm just going to move Sven's copy up there and set that up to be polygon as well. And if I need to apply a different material to Sven's copy, I'm just going to create another include graph, bring in the same operator, and so we have default on that guy. Let's set up red on this guy, and yeah, let's try and render this. So clearly we'd created a separate copy, but we hadn't done the material assignment yet. So let me select the operator graph here and set this to be include operator 2, and let's re-render. There, now we're starting to see there's a blue Sven and a red Sven, and both of them are being driven by the same look file, and our look file has multiple looks. So potentially you can imagine a scenario where, say, you have a crowd of characters and you have several different looks. You could come up with your own rule to make these sort of assignments, and they're just being driven by a single look file that has all of these different looks that you can apply to your assets. So there's one last thing that I still want to show you, which is to illustrate the fact that we still have complete control over this. So what I want to do is I'm going to be moving my camera to a completely different direction here. And if you remember, we actually set copper material on the red variant of Sven, right? I'm just going to disable the copper material so it goes back to some sort of a default. Let's try to see how we can do that. And so what I would do in that case is that's being driven by the include graph, right? So I would probably create a disable operator, and if you remember, I actually set the material to be copper underscore material. So if you have some sort of a rule to name things certain way, this will make things a whole lot more easier. So what I'm going to do is I'm going to set selection of copper underscore material, and if it finds copper underscore material, it will just disable it. And I'm going to connect that to my include graph. And what that should do is it should disable the copper material that's on red and default it to a Lambert. As you can see, what that did is disable the copper material that we set on it. So you still have complete control over being able to manipulate the scene and the shaders that are applied to it. So let me go ahead and remove that on Sven's copy. It was in the RUP network here, and there was a disabled node. So let me just remove that. So let's assume we're ready to render this out, but we get another note saying they want a slight look variation on the red Sven. Instead of having his hair in the color it is, they want it to be a little bit more darker. So what we would do in this scenario is go back to your look dev scene, just export another variation into a different file, and then quickly bring that in. So what I did is go back to my Maya look dev scene, just make a copy of his hair that's slightly darker and export that as version 2. So I'm going to change the file here, and you can see what I've had is I have our debug Sven red and default, but now I have Sven with his red color but black hair as well. So very quickly we'll be able to make those sort of changes. So you can see his hair on red is much darker than the hair on the blue suit. So yeah, I mean, this is one way for you to have all these non-destructive workflows for you to start building your character and your assets together, but anywhere in the pipeline still have complete control over what you want to manipulate and change. So finally, to make sure we have full round tripping, I'm going to be bringing in everything that we did in Houdini back into Maya and render them out. So let me create another stand-in. What I did from Houdini is export everything that we did from Houdini as another Arnold file. I called it 2Sven variation. Just going to load that file, and I already have my camera. Let's hit render. You can see in this scene I have absolutely nothing else but the single stand-in, but because everything has been put into that procedural, including all the changes that we did for thread material and the change to Sven's hair, all of them have been brought back in to Maya. We've successfully managed to take an environment from Max, a character from Maya, import them all into Houdini while still retaining the ability to control them at every point in the pipeline. We could reverse this pipeline and perform all the actions we just did, with Arnold being at the center of the pipeline. By using Arnold as the data driver, you get a lot of flexibility and control right out of the box. For the purposes of this demo, we chose Max, Maya, and Houdini, but Arnold would be able to support the same pipeline using any or all combinations of supported software. To learn more about Arnold in your pipeline, do check out these resources that are available on YouTube. Also, get in touch with us using Arnold Answers. It's our community forum, and all of our team are very active on it. It's a great place to get your questions answered by fellow users and also have some Arnold related conversations. Thank you for listening.